Okay, so day 7 notes is on continuing to find limits algebraically, but this time using what are called conjugates. We've seen conjugates in the past, and so a quick overview of what conjugates are. If you have something like x plus 3 and x minus 3, those are called conjugates. One would be a positive value, the other would be a negative value. And the good thing about conjugates is that those middle two terms, when you expand this, cancel out every time. So for example, when I expand this, I get x squared minus 3x plus 3x, and then a minus 9. And as you can see, the minus 3x and the plus 3x, both of those equal 0. So this just leaves us with x squared minus 9. The first two things multiplied together, x times x gives me x squared. Positive 3 times negative 3 gives me negative 9. Another example might be 2x plus 5, 2x minus 5. So we would get 4x squared minus 10x plus 10x minus 25. Again, middle two terms cancel out. 4x squared minus 25. 2x times 2x is 4x squared. Positive 5 and negative 5 is negative 25. This also helps for what's called rationalizing, and we'll get to that in some of the examples, but if we throw in some square roots, for example, square root of x plus 2 minus 5, then the conjugate of that would be square root of x plus 2 plus 5. And from what we've seen before, we don't even need to multiply the inside ones, so we're just going to multiply x plus 2, square root of x plus 2 and square root of x plus 2, which is square root of x plus 2 squared, or just x plus 2. And then when we multiply negative 5 and positive 5, we get minus 25. So when that conjugation is done, we end up with x minus 23. And that's where it's really going to come in handy, is using those conjugates with square roots. So let's take a look at some examples with limits. So in example A, you can see that we have this square root on top. So that's what we're going to use for our conjugate. So we're going to multiply square root of x minus 1 plus the square root of 3. And we're going to multiply that on top and bottom, because that's what you have to do in a fraction to make it legal. Alright, so when we multiply this on top, we still have the limit as x approaches 4. When I multiply the first two, square root of x minus 1 times square root of x minus 1, I just get x minus 1. I don't want putting parentheses, let me undo that. And then when I multiply square root of 3 times square root of 3, I get 3, but it's minus 3 because one of them was positive, this one was negative times a positive. And on the bottom, I'm going to leave the bottom just like it is, and I'll get back to that in a second. I've done enough of these to know that you don't need to change the bottom, because something's going to cancel out. So on top, this x minus 1 minus 3, that's the same thing as x minus 4. So that will cancel out with that, meaning that there was a hole at x minus 4, or at x equals 4, which leaves us with the limit as x approaches 4 of 1. Everything was canceled out on top, so when I cancel it out, there's a 1 left over square root of x minus 1 plus the square root of 3. And at this point, I'm going to try direct substitution. And when I plug in a 4, I get 1 over, I get the square root of 3 plus the square root of 3, which is 1 over 2 square root of 3. And that's a number, so that's good for an answer. Now, that's one thing I should have mentioned before we even started this. We should have tried direct substitution at the beginning. I already knew what was going to happen, so I skipped over that step on accident. But if we would have tried direct substitution at the beginning, we would have gotten 0 over 0, which would have let us know that there's a hole there, which is why I knew I didn't want to multiply this bottom part out, because I knew I wanted to cancel out that x minus 4. All right, example B, very similar. So let's go through example B. Again, direct substitution. If I plug in a 6, I end up with 0 over 0. To me, that means that there's a hole there. So I'm going to need to find where that hole is. And then, well, I know where the hole is. It's at 6. So what I need to do is cancel that out. So what I'm going to do is I'm going to multiply by square root of x minus 2 plus square root of 10 minus x on top and bottom. Square root of x minus 2 plus square root of 10 minus x. Don't let these positives or negatives on the inside of the square roots confuse you. It's just that one that's combining them together. That's going to be what changes. So because this one's negative, this one needs to be positive. All right, so on the top, I'm not going to multiply it out, but I'm going to recognize that there's a common factor of 2 in that top factor, so I'm going to factor that out, which is going to leave me with x minus 6, and then still square root of x minus 2 plus square root of 10 minus x. On the bottom, when I multiply these together, I get x minus 2. When I multiply x minus 2 times x minus 2, the square roots go away, and I get x minus 2 minus, and then I'm going to use parentheses here so I know to distribute. When I multiply square root of 10x minus square root of 10x, I just get 10 minus x, and that's going to go in the parentheses so I know to distribute that. All right, limit as x approaches 6. I still have 2x minus 6 square root of x minus 2 plus square root of 10 minus x. On the bottom, let's see, I get x minus a negative x, which is a 2x. I get a negative 2 minus a 10, that's a negative 12, which is very similar to what I have here. So again, this is factor out that 2 and I get 2x minus 6. So those two cancel out with those two, leaving me with the limit as x approaches 6 of just square root of x minus 2 plus square root of 10 minus x. And now I'm going to try direct substitution again. And when I try direct substitution again, I plug in a 6 and I get square root of 4 plus the square root of 4, which is 2 plus 2, 4, 4. And so there's my answer for there. All right, at this point, pause your video and check your work for the next two examples. All right, I'll assume that you have unpaused. If you want to take a look again, example A, very similar. When I try direct substitution, I get 0 over 0. So the conjugate is going to be square root of x plus 6 plus x. And then when I do my algebra, I end up with negative 5/6 at the end. Very similarly with part B, the direct substitution gives me 0 over 0. I'm going to use the conjugate of this one, which is plus. Again, work some algebra. The x plus 5s cancel out, leaving me with 2 root 2 as my answer.